I was born in the year of Sputnik, and I grew up during the great space race. I watched in utter awe as Neil Armstrong made his small step for man a giant leap for mankind. I followed the entire Apollo program, and especially the exciting drama of the Apollo 13 mission. Like most kids of my generation, I dreamed of being an astronaut. Fast forward, and I'm completing my sophomore year in engineering. I took 2 full semesters of calculus and another semester of differential equations. Now think about this. Most of my classmates and I were space fanatics. Yet in all that calculus and diff EQ, I had no idea that what I was learning was absolutely critical to spaceflight. What a huge difference that knowledge would have made in my motivation to learn. Better yet, I would have been thrilled to come to class to work on escape velocity calculations, orbital slingshot maneuvers, and anything else related to space. I also remember my circuits class, where it seemed we spent the entire semester analyzing these mind-numbing circuit diagrams. And I thought to myself, what are these circuits for anyway? Why should I care? Is this what electrical engineers do all day long? Because if it is, I don't want anything to do with it. In all honesty, those first 2 years of engineering education, after those first 2 years, I was exasperated. I felt like my passion had just been pounded out of me. One day, I was actually walking to my car to quit engineering for good. But thank God, I ran into a friend of mine. Now, he was pretty much in the same situation, wondering if engineering was right for him. However, he had just come from a meeting with Dr. Mickey Wilhelm, who had inspired him to stay a little longer. My friend insisted that I should go see Dr. Wilhelm before I left too. So I went to see him and I explained my frustration. He also convinced me to stay for at least 1 more semester to take one of his classes, and he assured me that he would connect the dots between the theory and the application. And he did just that. It turns out that Dr. Wilhelm had lots of industrial consulting experience, and he peppered his classes with authentic design challenges, industry examples, and experiential opportunities that connected the theory to practice. His class was relevant to me. I knew what I was learning, and equally as important, why I should care. And now look at me. Over 35 years as a professional engineer in a wide variety of settings. It's the classic story of there was this one teacher. Do you remember your one teacher? Thank you, Dr. Wilhelm. How many of our students today are wondering if they made the right decision in going into engineering? It's difficult to pinpoint the exact percentage of engineering students that either switch majors outside of engineering or leave college altogether. But most of the national data points to about 50%. Half of engineers across the nation either switch majors outside of engineering or drop out of college altogether. Now that's a serious problem. But wait, there's a solution, one offered by Dr. Wilhelm. We absolutely need to teach the theory. No one questions that. But we need to do a better job of connecting the theory to practice through authentic industry examples, design challenges, and experiential opportunities. Consider this. Relevance is a key component of every motivational theory. Not just learning theory, but all motivational theory. We want our students to be motivated to learn, yes? Of course we do. Then we need to continuously demonstrate the relevance, the why the learner should care of what we are teaching. We also know that the vast majority of engineering graduates will work in industry, broadly defined, and especially in their first years out of college. So the logical conclusion is that we should establish the relevance of engineering education through authentic industry examples, design challenges, and experiential opportunities. Now we can and should establish relevance in other ways too, through current events, societal issues, grand challenges, and other topics that are of importance to our students. But relevance to industry should be the priority. In my junior year, I took the course Facilities Layout and Design, and the relevance to industry was so strong that when I co-opted the following semester at a river barge manufacturing company, granted, a long way from NASA, but I spent the entire semester applying what I had just learned to their largest plate steel fabrication facility. It was an awesome learning experience, and it taught me things I could have never learned from a textbook. Let me give you a more recent example. Dr. Jun Ki Choi is an assistant professor of mechanical engineering at the University of Dayton. He developed a course called Design for Environment, also known as Sustainable Design. But rather than teaching from a generic textbook, he partnered with Crown Corporation, one of the 5 largest lift truck manufacturers in the world. Dr. Choi brought in several sustainable design experts from Crown who talked about their current projects, authentic industry examples. He also brought in Crown's director of design to talk about the broader business case for sustainable design. Equally as important, Dr. Choi brought all the students to a Crown facility to see firsthand their manufacturing operations, current sustainable design practices, and other things. Authentic, experiential opportunities. The students spent the remainder of the semester working on actual current design, sustainable design challenges for Crown. Authentic design challenges. At the end of the semester, the students presented their design concepts to a panel of experts from Crown, just as they would do if they were practicing engineers. Again, authentic experiential opportunities. This was a classic win-win-win scenario for the students, for the company, and for Dr. Choi. The feedback from the students was overwhelmingly positive. One student said, and I quote, "It's nice to take a class where we're working with a real company. Having a legitimate client rather than theoretical situations helps with motivation. I could not have said it better myself." It was a slam dunk for Crown on multiple levels. Direct access to bright students, diversity of thought, brand recognition. More importantly, the students' novel design concepts inspired a new design that is currently being implemented at Crown. For Dr. Choi, this experience inspired him to partner with industry in more of his courses. He won the School of Engineering's Vision Award for Innovation in Teaching, and students are flocking to his classes. Our keen mission is to graduate engineers with an entrepreneurial mindset so they can create personal, economic, and societal value through a lifetime of meaningful work, whether on river barges, lift trucks, or yes, even on the space station. But connecting the theory to practice, by connecting the theory to practice with authentic industrial examples, design challenges, and experiential opportunities. Thank you.